Here is the next example. In this example, he's asking about find V1 and V2. I will also find Ix. Okay, V1, V2 and Ix. Find V1, V2 and Ix in the given circuit. A simple way of writing circuit is CKT. In electrical engineering, usually we write circuit as CKT. Now when you look into the circuit, it's look like very difficult. It's look like everything open, but in reality, look at this. This is grounded here. The voltage here is 0. The voltage here is 0. If both of them have the same voltage, what we can do, we can kind of short circuit it. It's not going to work for every circuit, especially with operational amplifiers, which you're going to learn in the future. Okay, but here what I can do, I can combine these two, all of them. I mean, what I did, I connected every ground here. Now our goal is finding V2. So how do you get V2? I'll tell first, since he's talking about nodal analysis. Step 1, find, label all the node values. He's already using V1 and V2 here, so I want you to use different values. So I'm going to choose VA, VB, VC. Okay, so V2, he's asking about V2. Can I write V2 equal to VC minus VA? Okay, and at the same time he's asking about V1. Okay, so basically you have the voltage at this point. Can I take that as V1? Because the voltage between this and ground is V1, ground value is 0, so the voltage must be V1 there. Okay, now you have 5Ix. What kind of source is this? This is a voltage source. I mean, as long as you have plus and minus inside, that's a voltage source. You have rhombus, so it's a dependent source. It is depending upon Ix. Ix is given right there. Okay, so it's a current dependent voltage source. Whatever, if Ix changes, this value is going to change. Okay, now that's V1, that's VC. Okay, so can I say V1 minus VC equal to 5Ix. Okay, what about Ix there? Ix is nothing but so let me simply write V1 equal to 5Ix plus VC. What is Ix? Ix is nothing but, in this case, VB over 20. So V1 equal to 5 times VB over 20 plus VC. That's my V1. Okay, so these are the equations I have. Now all I need to do is find VA, VB, VC. Okay, at VA, do we need to apply KCL? No, because the reason behind it is there is a voltage source between VA and V reference. So can I take so this value as V reference? Okay, so V reference minus VA equal to 10 volt. Always choose the positive. Okay, positive as V reference. So that's the reason V reference minus VA equal 10 volt. So what is VA? VA equal to negative 10 volt. Okay, I found VA. Okay, now can I apply KCL at VB? So at VB, apply KCL. At VB, apply KCL. So here he already chose Ix, so I'm going to choose this as Iy and Iz. So Ix plus Iy plus Iz equal to 0. What is Ix? Ix is nothing but VB over 20. Iy is nothing but plus 5 amperes. Okay, Iy and 5 amperes flowing in the same direction, so I can choose Iy equal to plus 5 amperes. And Iz is nothing but VB minus VA, which is VA equal to minus 10 volt divided by 10 equal to 0. Okay, let me simplify this. I'm going to multiply this with 20. So VB plus 100 plus 2VB plus 20 equal to 0. So 3VB equal to minus 120, VB equal to negative 40 volt. Okay, I end up with VB value as negative 40. So what is IX? Negative 40 divided by 20, negative 2 amperes. So current is flowing in the opposite direction. Okay, now at VC apply KCL. I'm going to use the side notes here. Let me see. Okay, at VC apply KCL. So if I apply KCL at VC, I'm going to choose every current is going out: I1, I2, I3, I4. What is I4 in this case? Remember, this is a source and this is not connected to any other loads. Okay, it's kind of open. So basically it's kind of extension cord. You're plugging into your wall your extension cord, but nothing is plugged into the extension cord. That means it's not going to supply any current. So basically I can take this current as 0 ampere, but still there will be some potential difference available there though. Okay, so I1 plus I2 plus I3 plus I4 equal to 0. What is I1? I1 is nothing but negative 5 amperes. I2 is nothing but VC over 20. I3 is nothing but minus 2 ampere. Okay, plus I4 is nothing but 0. So VC over 20 equal to 7. So VC equal to 7 times 20, which is 140 volt. Okay, so now I know VC value. So once I know VC, can I find V2 value? V2 is nothing but VC minus VA. So V2 equal to VC minus VA. VC we have 140 minus negative 10. So V2 equal to 150 volt. So that current source has a potential difference of 150 volt. And V1 is nothing but 5 times VB over 20 plus VC, right? So VB, we just found that VB equal to negative 40 volts. So V1 equal to 5 times negative 40 over 20 plus VC equal to, I have 140 volt, VC equal to 140. So minus 2, which is V1 equal to minus 10 plus 140, V1 equal to 130 volt. So we found V1, we found V2, we found IX. Okay, that's the quantities he's asking for. We found all three. Okay, so when you look at the circuit, initially it might look like scary, but once you start thinking about or solving it, you'll find it easier. So to solve by using either nodal analysis or mesh analysis, you need to practice lots of examples. Okay, I try to provide it as many as possible, but next video probably I'll start solving super nodal analysis. Thank you.